Ford's CEO Jim Farley recently unveiled a game-changing innovation that could reshape the future of the automotive industry. His announcement of a revolutionary new engine, one that directly challenges the growing dominance of electric vehicles, has sent shockwaves through both the automotive and energy sectors. This bold move underscores Ford's unwavering commitment to staying at the forefront of an increasingly competitive market, proving that the company is not just adapting to change but driving it forward with groundbreaking solutions. This cutting-edge engine marks a major turning point in the evolution of internal combustion technology, defying the widely accepted belief that the industry is inevitably heading toward an all-electric future. Unveiled at a highly anticipated event, the new engine is the result of years of advanced engineering aimed at delivering both exceptional performance and reduced environmental impact. Unlike conventional internal combustion engines, this next-generation powertrain is designed to be remarkably efficient, more eco-friendly, and even capable of rivaling some of the most advanced electric vehicles on the market. This move could reshape the conversation around the future of transportation, ensuring that innovation extends beyond just one path forward. The new engine also boasts impressive fuel economy, achieved through a combination of advanced materials, innovative combustion techniques, and proprietary software designed to optimize performance in real time. One of the most significant aspects of this engine is its environmental profile. Ford has integrated cutting-edge emission reduction technologies, allowing the powertrain to produce significantly lower levels of pollutants compared to conventional internal combustion engines. This advancement addresses a key criticism of traditional engines, which have long been seen as major contributors to greenhouse gas emissions and urban air pollution. By achieving such breakthroughs, Ford challenges the perception that only electric vehicles can lead the way to a greener future. This development not only provides a sustainable alternative for regions where EV adoption is slower due to infrastructure challenges but also ensures compliance with increasingly stringent global emission standards. The impact of this announcement extends beyond the automotive industry, influencing various related sectors. The energy industry, for instance, could see a shift in demand patterns as the adoption of Ford's advanced engine technology grows. Unlike EVs, which rely heavily on electricity generated from renewable and non-renewable sources, Ford's engine offers flexibility in fuel usage, potentially paving the way for the wider adoption of cleaner synthetic fuels or biofuels. This adaptability could reduce the strain on existing power grids, which are already facing challenges in regions with rapid EV adoption. The implications for the global supply chain are equally significant. Electric vehicles depend on a complex and often geographically concentrated supply chain for batteries, particularly involving rare earth metals such as lithium, cobalt, and nickel. These resources are not only limited but also raise environmental and ethical concerns due to the mining practices involved. Ford's new engine offers a compelling alternative, potentially reducing reliance on these materials and providing automakers with a more sustainable and ethically sound production model. Beyond the technological and environmental implications, Ford's engine has a cultural significance that cannot be overlooked. The internal combustion engine has long been a symbol of human ingenuity, a marvel of engineering that defined the 20th century. It represents the freedom of the open road, the thrill of acceleration, and the mechanical artistry that has captivated generations of drivers. By reinventing the internal combustion engine, Ford preserves this cultural legacy while adapting it to the demands of a changing world. This balance of heritage and innovation resonates deeply with automotive enthusiasts and reinforces the emotional connection many people have with their vehicles. The geopolitical ramifications of Ford's engine are equally significant. The global push for electric vehicles has concentrated power in regions that dominate the battery supply chain, such as China, which controls a substantial portion of the world's lithium processing capacity. By reducing dependence on batteries, Ford's innovation could decentralize this power dynamic, offering a counterbalance to the growing influence of battery-producing nations. This shift could lead to greater energy independence for countries that rely on imported batteries and rare earth materials, fostering a more equitable global energy landscape. Ford's announcement also forces policymakers to rethink existing regulatory frameworks. Many governments have implemented aggressive timelines for phasing out internal combustion engines, often under the assumption that electric vehicles are the only viable solution for reducing emissions. Ford's engine challenges this narrative, demonstrating that advanced internal combustion technology can achieve comparable environmental outcomes. This could lead to more flexible policies that incentivize innovation across a broader spectrum of technologies rather than favoring a single solution. Such an approach would encourage healthy competition and accelerate progress towards sustainability. The competitive landscape within the automotive industry is likely to shift dramatically as a result of Ford's announcement. Automakers that have fully committed to electrification may find themselves reevaluating their strategies in light of Ford's innovation. Some may choose to reinvest in internal combustion research, while others may focus on hybrid solutions that combine the best aspects of internal combustion and electric propulsion. The diversity of responses will spur a new era of experimentation and creativity, driving the industry toward greater innovation. Ford's engine also has implications for mobility solutions beyond passenger cars, significantly impacting the commercial vehicle sector. Commercial vehicles such as trucks, buses, and heavy-duty machinery are often seen as one of the most challenging segments for electrification due to their unique operational demands. These vehicles typically require extensive range capabilities, high performance under heavy payloads, and quick refueling times to maintain efficiency in industries such as logistics, public transportation, and construction. The current limitations of electric vehicle technology, including long charging times, limited battery range, and the weight constraints associated with large battery packs, have made the transition to full electrification in these sectors particularly difficult. Ford's new engine technology presents a compelling alternative by addressing many of these concerns. It provides a powertrain solution that combines improved fuel efficiency, reduced emissions, and high performance, making it a viable option for industries that rely on heavy-duty transportation. By integrating advanced combustion techniques and cutting-edge materials, Ford has designed an engine that offers the durability and reliability needed for commercial applications while maintaining a lower environmental impact compared to traditional internal combustion engines. This breakthrough could revolutionize the way commercial fleets operate. Currently, many logistics companies are hesitant to transition to electric trucks due to the high costs associated with purchasing EV fleets, the need for extensive charging infrastructure, and the potential for downtime caused by long charging periods. Ford's innovation provides an immediate and practical solution that enables companies to reduce their carbon footprint without sacrificing efficiency or profitability. For businesses that operate in remote areas where charging infrastructure is scarce, this new engine offers a more accessible and cost-effective alternative. Public transportation systems, including city buses and long-distance coaches, could also benefit from this technology. Electrifying an entire fleet of buses requires significant investment in charging stations, grid upgrades, and fleet management strategies. By offering a cleaner and more efficient internal combustion engine, Ford is providing municipalities with a transitional option that reduces emissions while maintaining operational feasibility. This could help bridge the gap between traditional fossil fuel-powered transit systems and the eventual widespread adoption of sustainable mobility solutions. Additionally, the construction and agriculture industries, which depend on high-powered machinery and heavy-duty vehicles, stand to gain from Ford's innovative engine. Many of these machines operate in off-road or rural environments where electric charging infrastructure is virtually non-existent. The ability to maintain powerful, fuel-efficient, and lower-emission engines in these industries ensures continued productivity without the limitations imposed by battery-powered alternatives. Beyond commercial vehicles, Ford's new engine technology could also influence policy decisions regarding alternative fuel sources. The adaptability of this engine to work with synthetic fuels, biofuels, or even hydrogen-based combustion opens up new possibilities for reducing global dependence on traditional fossil fuels. This could lead to wider acceptance of hybrid solutions that blend combustion efficiency with lower carbon footprints, ultimately contributing to a more sustainable transportation ecosystem.